Hi everyone, welcome to week 2 of distance learning. We are going to continue with probability today. We're going to be learning about independent and dependent probability, which should hopefully be a little bit new for you guys and something that you haven't learned yet. This week is actually going to be a short week because you don't have any class on Thursday and Friday of this week due to Easter break. So you only have to do math Monday, Tuesday, and Wednesday. We're going to do some independent, dependent events today. We're going to review that tomorrow. And then I think on Wednesday, we'll do some stuff with odds. So here we go. Let me get rid of my face on there. Okay, independent and dependent events. So what is that? Now, an independent event is... this is not working. Hi guys, welcome back for week 2 of distance learning. You guys have no idea how much I miss seeing you all in my classroom every day. But hopefully this is working out okay. This is actually going to be a shorter week. Brecken showing you his lunch in the background. Because of Easter this coming weekend, we only have school Monday, Tuesday, and Wednesday. So you only have work to do for those 3 days. All week, we're going to continue learning about probability and a few new topics on probability. So let's go ahead and get started. Today, we are going to learn about independent and dependent events. So an independent event is when the occurrence of one event has no effect on the probability of the second event occurring. Okay, so that sounds kind of confusing. I don't know if anybody understood that or not. But what it really means is if I flip a coin and then I had to flip a coin the second time, what happens the second time is not impacted by what happened the first time. Okay, so we'll do some examples of this and hopefully it will make sense. So in mathematical words, it's the probability of A and B, flipping a coin 2 times, is the probability of A times the probability of B. Okay, so for example, what is the probability that you're going to roll a 3 on one number cube and roll a 2 on another number cube? So the probability of rolling a 3 and rolling a 2. Well, these are independent events because one does not affect the other. Okay, so the probability of rolling a 3 is 1/6. And the probability of rolling a 2 on a number cube is 1/6. So the probability of rolling a 3 and then a 2 is, you multiply those together, 1 times 1 is 1 and 6 times 6 is 36. So our probability would be 1/36. Okay. Now, if they're dependent events, that means that the occurrence of one event does have an effect on the probability of another. So we're looking at the probability of A and B, and the probability of A times the probability of B after A. Now that seems super confusing right now. I promise I will try to make this easier. So for example, if I choose a 7th grader to be on a team from a group of 10 7th graders and 10 8th graders, then choose a different 7th grader from the remaining students. Now this is a dependent scenario because after you pick one person, they're already picked. They can't be chosen again. So the probability that the first time I would pick a 7th grader is 10 out of 20 kids. The second time I go to choose out of the bag, the probability, there's only 9 7th graders left to choose from out of 19 students. So remember, this total number changed also because you already took one student out. So multiplying this, I'm going to simplify this first. 10 over 20 simplifies to 1 over 2. And then we multiply. So 1 times 9 is 9. 2 times 19 is 38. So we have a 9 out of 38 chance of choosing a 7th grader and then another 7th grader. Okay. So here's a couple examples. Decide whether each set of events is independent or dependent and then calculate the probability. So Kathy draws a 4 from a set of number cards numbered 1 through 10 and rolls a 2 on a number cube. Okay, first of all, these are independent events. Okay, they're independent because drawing the 4 from a set of cards has no impact on what you're going to roll on a number cube. It doesn't affect it at all. So they are separate items, so they're independent from each other. Okay, so if I want to find the probability of drawing a 4 and then rolling a 2, I need to find the probability of 4 first times the probability of rolling a 2. So let's start with the 4. Probability of a 4, it's 1 out of the 10 cards, times the probability of rolling a 2 would be 1 out of 6. So the probability of both of those things happening is 1 out of 60. Okay. Number 2, a reading list contains 5 historical books and 3 science fiction books. What is the probability that Juan will randomly choose a historical book for his first report and a science fiction book for his second? Now, in this case, these are dependent events. Okay? They are dependent because when you pick one item, if you pick one book out, you're not going to pick that book again. You're changing how many books you have to choose from. So we want to find the probability of a historical book and then a science fiction book. So let's start with the probability of a historical times the probability of science fiction. Okay, there are a total of 8 books. So the probability of historical is 5 out of 8. Once we pick a book, assuming it's historical, now we have to find the probability of a science fiction, which there are 3, but it would be 3 out of 7 because we already chose one book. We finish by multiplying these fractions. I can't simplify anything. 5 times 3 is 15. 8 times 7 is 56. So our probability is 15 out of 56. All right, so let's finish up with just a couple more examples. So again, tell whether they're independent or dependent, and then we're going to find the probability. So if you roll a number cube twice, those would be independent events because rolling the number cube one time doesn't affect the other. Okay, so first roll you roll a 4, the second one you roll an even. The probability of a 4 times the probability of even. So the probability of a 4 is 1 out of 6. The probability of an even number is 3 out of 6. We can simplify the 3/6 to 1/2. So that would be 1 out of 12. Okay, you flip a coin twice. Flipping a coin is independent events because one does not affect the other. So the probability of heads on the first flip and then the probability of heads again would be 1/2 times 1/2, which is 1/4. So our probability would be 1/4. You randomly draw a marble from a bag containing 2 red marbles and 5 green marbles. You put the marble back and then draw the second marble. Because you put the marble back, these are independent events. If you wouldn't have put it back, it would be dependent. But because you put it back and returned everything to the bag, that makes them independent. So the probability that the first draw is green and the probability that the second draw is red. Okay? The first one is 5 out of 7 and then 2 out of 7. So we multiply those together. That's 10 out of 49. You randomly draw a marble from a bag that contains 2 red marbles and 5 green marbles. You keep the marble and then draw a second marble. Now, because it said you keep the marble, that makes it dependent. Okay, so the probability that the first is green and the second is red. The probability of green times the probability of red. Green is 5 out of 7. Now, remember, we kept that marble. So now the probability of red is 2 out of 6. Before I multiply here, I'm going to simplify to 1 over 3, and then multiply. 5 times 1 is 5, 7 times 3 is 21. So the probability is 5 out of 21. Okay, you and your friend are in a drawing for 2 door prizes. You can only win 1 prize. So what's the probability that your name is drawn and then your friend's name is drawn? Because once your name is picked, it is kept out of the bag. That means these are dependent events. So the probability of you times the probability of your friend. The probability of your name being drawn is 1 out of 2. The probability of your friend being drawn is going to be 1 out of 1, since you're already taken out. So that means the probability of you being drawn first and your friend being drawn second is a 1/2 chance of that happening. Okay? Hopefully that all makes sense. You will have a Canvas quiz to answer some questions about independent and dependent events. So look for that. The next thing in the module will be a Canvas quiz. We are going to spend some more time doing some things with independent and dependent events tomorrow. So this isn't the only day we're going to do this. So if you found this a little bit confusing today, try your very best. Know that I will be on I'll be on Zoom, so you can ask questions tomorrow and every day. But short assignment on this tonight, and then look for more of independent, dependent stuff tomorrow. Thanks, guys. See you tomorrow.